Hi guys, am I audible and visible? Let's check it out. Oh, alright, I am. Hello. Okay, so hello, as I always say, namaskara everyone, andariki namaskaram, ellarku swagatam and a very warm vanakkam to VEDANTU JEE English channel. This is me, your master teacher Nabamita and Durgesh, and today we are going to do one of the most highest weighted chapter for EAPCET for both TS as well as for AP everybody, and that chapter, my dear student, is your coordination compounds. Yes, and even in coordination compounds I'm going to take you through the most important type of questions. Yes, so please pay attention and stay till the end of the session just so that you understand how to solve each and every question that I'm going to take you in this session. How long will the session be? The session will be around 30 to 45 minutes. Not more than that, since I'm starting with one of the most highest weightage chapter today, that is why I'm going to take less time. But as we move on from here, I will be taking longer sessions. Alright everybody, yes, please explain in Telugu. I am so sorry sweetheart, I do not know Telugu. I cannot speak in Telugu. Also, this is a JEE English channel. Hence, I'm only going to be able to explain things to you in English, everybody. Yes, if you want to learn in Telugu, then we have Vedantu Telugu also. You can go to that channel and you can watch it. But here, I'm going to take the session in English. Alright, everybody. Hema, I will do that. Don't worry about it, but not today. Not today. Today we are going to solve questions. I will take another session wherein I will be telling you all the highest, most important topics and everything. Okay? Alright? Yes, absolutely. Why not? Okay, so quickly go ahead and call up your friends, everybody, and don't forget to hit the like button, guys. If you don't like the session, we will not understand if you really want this type of sessions or not. So please don't forget to hit the like button, everybody. Love you too. Thank you so much. Thank you so much. Sweetie, we will try to do that. I can't promise it right now though. I'll try to do that, okay? I will try to do that, yes. Okay, so shall we start with the session, guys? Everybody, are we all here? Yes, bacha, yes. We will take advanced as well. Don't worry. This channel is going to be your one-stop solution for everything related to 11th and 12th. Don't worry about it. Yes, we are here, we are well, and we are going to help you. We are basically your friends on internet, okay? Don't worry about it. Chalo, guys, let us solve, everybody. Yes, are you all with them? Are you all with me? Hi, bachos. Hello. Yeah, we will take advanced PYQ also, Vijaya, but right now, can we do EAPCET? Chalo. So the first question, everybody, is on your screen, and the first question, see, this is a EAPCET 2023 question. This is a last year question, and this type of question, I have seen that it gets repeated a lot of times, like literally a lot of times this type of questions gets repeated. So read the question, everybody. Which of the following is correct and related to the colors of TiCl3X and TiH2O6Cl3, which is compound Y. So basically you are given two compounds, one is X and one is Y, and you have to find out what is the color for these compounds. Okay, alright, they are not asking you to exactly tell you the color, but what they are saying is the compound is going to be colored or the compound is going to be colorless, right? Now, what is the concept here, guys? What is the concept, everybody? Both are colored. Both are colored. Seriously, both will be colored. Chalo, let us take a look at it. Yes. Now, what is the concept here, my bachos? The concept that we are going to use here is unpaired electrons. Okay, we have to find unpaired electrons. If there are unpaired electrons, that means that the compound is going to be colored, and if there are not unpaired electrons, that means the compound is going to be colorless. Okay? So now let us try and take a look at the first compound, which is TiCl3. Okay? How do you find out how many number of unpaired electrons are there? The first thing that you are going to do is you are going to find out the oxidation state. Okay? So let us say that X is titanium. Okay? X is titanium. And we know that chlorine atom, chlorine ions, they have -1 charge. What do they have? They have 1 negative charge, my bachus. So that means that there are three of the chlorine ions, see, as you all can see, isn't it? So that means that we will take 3 multiplied with -1, and overall there is no charge. Do you see any charge whatsoever on this compound? None whatsoever. So what are we going to do? We will equate this with 0. Okay. Now that means that X's is equal to 3. Am I right? Now tell me, who can tell me what is the atomic number of titanium, guys? What is the atomic number of 21, my bachus? Yes, what is the atomic number of titanium? Scandium is what? Yeah, reality viewers, how many times will you ask me the same question, bacha? How many times will you ask me the same question? And how many times do you want me to tell you the same answer, bacha? How many times have I told you that the setup, the big screen costs 5 lakh? I don't have 5 lakh rupees. If you can give me 5 lakh, I'll put it up. Okay. In the office, there are many teachers. You have to book the studio. It's a lot of, studios are less, there are a lot of teachers. Hence, I like this. I find it better. So why don't you, you keep asking me this question every single time. Anyway, okay. Alright. Yes. 1 second. Chalo, no problem. This is what? What did you say? This is Y is colored. No, let's make it colorless. Don't worry about that. Chalo, here we are going to make it colorless. See, now we're going to make it colorless. Okay. Alright, everybody. Yes, this is done. These two are colored. Okay. Now you want me to change this? Chalo, I'm going to change this also. C. Okay, both are colorless. Now it's fine. Okay. Titanium has an atomic number of 22. Very good. So 22. If it is 22, then the electronic configuration is going to be 3d2, 4s2. Am I right? Very good. Absolutely. Now you can see that titanium is in +3 oxidation state. That means 3 electrons it is going to give away. 3 electrons, if it gives away, then it will have 3d, 1 electronic configuration, and since there is 1 unpaired electron, that means that this compound will be colored. Okay, this compound is going to be colored. Makes sense? Great. Okay, now let us solve the other one. Okay, let us solve it for TiH2O6Cl3. Right, this is our compound. Okay, for this also, chalo, let us find out the oxidation state. Now, how many of you know that H2O, water, is a neutral ligand? How many of you know this, that water is a neutral ligand? Everybody, yes? How many of you know that water is a neutral ligand? You all know? Very good. Okay. So that means X plus 6 multiplied with 0, because now take a look at it. Now take a look at it, everybody. See, Cl3 is here. Now we all know that Cl has what? Negative -3 charge. If the counter ion here is negatively charged, that means this coordination compound will be +3. Yes. Why did I say it? You must have seen NaCl. If it is NaCl, what happens? It will become Na plus Cl minus. Similarly, if this is -3, that means that here we will have +3. Right, everybody? Absolutely. So this will be equal to +3. That means once again X's is equal to +3, and we have just seen that if titanium is in +3 oxidation state, it will have 1 unpaired electron. Hence, this is also going to be colored. So what is our answer, guys? What is our answer? Our answer, my dear student, is option C. Okay, our answer, my dear student, is option C, that is colored. Okay, your answer is option C, that is colored and colored. Okay, both of them are colored. All right, everybody. Yes. Okay. Now moving on. See, another EAPCET 2023 question, everybody. This is also a previous year question. Now tell me, identify the species which does not exist. Okay, which one of this does not exist? Come on, tell me. Yes, gamer, you are absolutely right. Ti +4 is colorless because it does not have a single electron. It does not have any electron in the d orbital or in the s orbital. Hence, this is colorless. All right. Yes, everybody, very good. Chalo. Now, identify the species which does not exist, everybody. Take a look at it. See, SiF62-, it does exist. Why so? Because fluorine atoms are very close, fluorine atoms are very small, and silicon being a little bigger ion, it will be able to accommodate all the chotu fluorine ions. Alright, yes. But if you take a look at SiCl6, now when you compare the size, chlorine atoms or chlorine ions are bigger than fluorine atom, and for silicon it becomes really tough to accommodate all the 6 big chlorine atoms around it, and that is why this is the compound that does not exist. Okay, this is the compound that does not exist. All right, yes, germanium with Cl6, it will exist. SnOH6, it does exist. It's only option B that does not exist. Am I clear, everybody? Guys, the correct answer is option B. Okay, the correct answer is option B, not option A, not option C. It is option B. Why so? Because when you compare, what happens is Si with F6, 6 fluorine atoms, they can surround the silicon atom, but 6 chlorine atoms, they are bigger in size and they will not be able to be there. Okay, they will repel each other and that compound will be unstable. Okay, alright, Chintu, I have just told you how to know is to find out number of unpaired electron. If there are unpaired electron present in the d orbital, that means that the compound is going to be colored. If there are no unpaired electron, or if it is completely filled, if you find D0 or D10, okay, there are no unpaired electron, that means that the compound is going to be colorless. Okay, Chintu? Understood, everybody? Yes? Chalo, guys. Moving on to the next question here. The next question, everybody, is the homoleptic complex in the following is. My God, this is such an easy question. Homoleptic complex, you know what is homoleptic complex? Homoleptic complex means those compounds which have only one single ligand, like, you know, those compounds which have only one type of ligand attached. Okay, only one type of ligand attached. Okay, what did I say? Those compounds which have only one single type of ligand attached to the central metal atom. Okay, attached to the central metal atom. Am I right, everybody? Yes. So now if you look at the option A, everyone, see, this has 2 types of ligand, isn't it? There is bromine and there is amine also. So there are tetraamine dibromido. This is not homoleptic. This becomes heteroleptic complex, right? Now look at this. Here you have oxalate ion. See, C2O4. Here you have oxalate as well as amine. So this also cannot be homoleptic. This is also heteroleptic. But now look at this. CONH36. What will be the name? The name here will be hexaamine cobalt. So yes, because all of them are only one single type of ligand, that means that option C is your homoleptic complex. Very good, everybody. Quickly clap for yourself. Sakshita, Hema, Gamer, Queen Lucky, Radha Krishna. Well done, well done, well done, everybody. Yes. Now tell me something. Are you guys liking the session? Everybody, do not forget to like the session, guys. I'm seeing that many of you are watching the session, but you're not liking the session. If you don't like the session, we will not bring this type of sessions. Okay, you have to like the session, bachos. Okay, all right. Saiti, we will see, bacha. We will definitely try. Okay. Yes, yes, yes. You can. Rani Priya, you can. Absolutely, you can. Okay. At least you will get certain type of idea. And do tell your friends also. Those of you who want to learn in English, EAPCET in English, this is the channel to follow. Nobody else is doing it, everyone. So this is the channel to follow. Otherwise, you can always go for the Telugu channel also. Okay? Do tell your friends, huh? Chalo, guys. Next question, everyone. The set which has only ambidentate ligand. Guys, what is ambidentate ligand? What is ambidentate ligand? Does anybody know what is ambidentate ligand? You know, you must have heard about this term, no? Ambidextrous. Or how many of you have watched the movie Three Idiots, guys? Tell me. How many of you have watched the movie Three Idiots? How many of you have watched the movie Three Idiots? Quickly tell me, Three Idiots. How many of you have watched the movie Three Idiots? And you remember that Professor Virus? Yes? ठीक है. ठीक है, ठीक. Yes, Krish. Almost same type. No, quickly go, guys. Don't answer. Let's have a conversation here. Tell me something. How many of you have watched the movie Three Idiots? Bidentate and polydentate are different from ambidentate, bacha. It's different from ambidentate. Yes. Have you all watched it? Have you all watched that movie Three Idiots? Now, do you remember Professor Virus, do you remember he used to write on the board with both the hands? Yes, do you remember? He used to write on the board with both the hands. Do you remember? Yes, to save time. Exactly. And you know what those type of people are called? They are called as ambidextrous. What are they called? They are called as ambidextrous. Okay? Alright. That means that, see, I will be able to only write with my right hand, right? But Professor Virus, he could write with left hand. He could also write with right hand. He could write with left hand. He could also write with right hand. So that means the type of ligand which can hold on to the metal with the left hand or with the right hand, they are called as ambidentate. Okay? And ligands don't have hands, obviously, which you know, right? Ligands are not human beings. Ligands don't have hands, but what do the ligands have? The ligands, they, my dear students, they have donor sites. What do they have? They have donor sites. That means through that site, they can give some electrons, okay? Through that position, they can give some electrons. Are you getting my point, everybody? Yes. Now, there are donor sites. There are different donor sites. Like there are F minus, Cl minus, Br minus. These are all what? These are all monodentate. Monodentate means they can only hold on to the metal atom with just one finger or one donor site. Okay? Alright, very good. Now, you must have seen some other donor sites like OHO. Oxygen is a donor site, okay? Then you must have seen C2O4, right? Carbon is a donor site. Oxygen is also a donor site. Check it out, guys. Now, if I write NO2 or if I write ONO, same thing. NO2, there are two oxygen. Now, I have written ONO, same thing. So, either it is holding with the oxygen side hand or it can hold on to the metal with the nitrogen side hand. Okay, you must have seen another ligand which is NCS or SCN minus. Have you seen that? Exactly. So, see, it can either hold on with the nitrogen hand or it will hold on with the sulfur hand. Then you must have seen Cn minus. So these are all, option B is your correct answer. All of them are ambidentate ligand. NO2, ONO, Cn, NC, SCN, NCS. These are all ambidentate ligands. And by the way, one thing that you must remember, everybody, is that the ambidentate ligands, my bachus, are always, are they bidentate? No. Are they polydentate? No. They are always monodentate ligands. That means when they are holding the hand, it will not be like this, okay? It will not be like a chotu bachcha and holding hands both the sides. No. They are only going to hold hand one side, okay? Always through just one donor side, they will hold on to the metal. So they always act like a unidentate or a monodentate ligand. Am I clear, everybody? Is this much clear? Does anybody have any doubt here? Does anybody have any doubt here? Yes? Do they? Do they? Yes? Anybody has any doubt here or everybody is clear, guys? Are we all clear? Are we all clear? Are we all clear? The difference between ambidentate and, see, ambidentates are always unidentate, monodentate. Ambidentate ligands are always monodentate ligand, but ambidentate ligands, basically you have to understand this, okay? Okay, let's say that, what is the difference between, what is the difference between a starfish and a lizard? That's the sort of question that you are asking. A starfish has 6 hands, alright, but a lizard has only 1 tail. A starfish, let's say, has 6 tails, but a lizard has only 1 tail. You understanding, everyone? You understanding? NH3 is ambidentate? No. NH3 has only 1 donor side, and that will be nitrogen. NH3 does not act like an ambidentate ligand. NO2 acts like an ambidentate ligand. Okay? Chelating ligands are polydentate ligands, more than bidentate ligands when they hold on to the metal. Basically, imagine if this is a metal, okay? This is the metal atom. And if so, you know, wait, I'll show you. Okay. So imagine there are, let's say that there are 5 fingers of a ligand. And if the ligand is holding on to the metal like this. Now, if you look at this, does it form like a ring structure here? Does it not form like a ring structure here? So that is called as a chelating ligand, okay? A chelating ligand can form like a ring structure when two or more than 2 donor sites hold on to the metal. They form like a ring, and that's called as chelating ligand, okay? Alright, understood, Amaresh Udayagiri? You were asking about chelating ligand, right? This is clear? This is clear? Okay? Alright? C2O4 is a bidentate ligand. Yes, then you have you know, bidentate ligand. You have pyridine. Yes, then you have EN. EN is a bidentate ligand. Okay, so there are different you know, there are different ligands. Okay, type of ligands. But please, yeah, Kiran sir, whoever you are, please, yeah, don't, you know. I don't know why you didn't get updated with digital. I don't have so much money, like I told you. I don't have so much money. Yes, I don't have so much money. That's it. So don't keep asking about this. I hope if you like it, you study. You don't like it, you want a digital board. If you think that digital board is the only thing that can make you get marks, sure, please go to somebody else's class. Don't disturb this class and, you know, keep taking that, ma'am, why you not take class? Why you don't take class from digital board? It's not gonna happen. I'm not gonna get a digital board. Also, even if Vedantu gives, I don't want to, you know, spoil the room and you know, do all of these things. I like this. This is it. This is all that is. Okay? All right? Yes. Now don't keep asking the same question, everyone. Yes. Anything else? EDTA. Now EDTA has different ions. There is EDTA 4 minus. There is EDTA 5 minus. EDTA 4 minus is a pentadentate ligand. EDTA 3 okay, sorry, no. There is EDTA 4 minus, EDTA 5 minus. So EDTA 5 minus becomes a hexadentate ligand, 4 minus becomes a pentadentate ligand. So based on what is the charge, EDTA can act like, you know, different, EDTA can have different denticity. Okay? Alright? Okay? Got it? Got it. Thank you, Chintu. Thank you so much, guys. Yes. Yes, Hema, absolutely right. Absolutely right. Getting it, everybody? Are we all clear? Are we all clear with the denticity? Do you all know what is denticity? Everybody understood what is denticity? Denticity is basically, you know, the teeth. How many teeth with how many? You guys have seen those clutches, no? Your mom or your sister may use probably, you know, these clutches that they use for hair. Have you seen, guys? Have you seen, everyone? Have you seen? So exactly, you know, there are clutches which have only just 2 teeth. So that's like a bidentate ligand. There are clutches which have like 3 teeth, you know, 6 teeth. So that becomes like a, you know, so that becomes like a hexadentate ligand. You get it, everybody? Yeah, exactly. So that sort of thing, that is your denticity. That's it, that's it. It's very easy, okay? It's very easy. Chalo guys, moving on, let's do this, okay? The correct order about the number of unpaired electrons present in the following complexes are, everyone. Chalo guys, let us check this out, okay? The first one, the first compound here is FeCN6 4 plus. Okay, here it is written as 2 minus. It can't be 2 minus. It has to be 2 plus. Okay, it has to be 2 plus. So FeCN6. Now, everybody, first of all, let us find the oxidation state. So let us say that Fe is X plus Cn has 1 negative charge, by the way. Okay, Cn has 1 negative charge. So plus minus 1 multiplied with 6 here, okay, and see the overall charge here, everybody, the overall charge here is 4 minus, so I'm going to write here minus 4, okay. Now if you calculate this, x minus 6 will go that side, it will become plus 6, so that means it will be x is equal to plus 2. Alright, now Fe, what is the atomic number of iron, guys? Atomic number of iron, my dear student, is 26. That means the electronic configuration becomes 3d6 4s2. But now we have just calculated that iron is in plus 2 oxidation state. That means it will be 3d6. Am I right, everybody? Am I right, everyone? It will be 3d6, but choose 3d6. Okay. Now, Cn, everyone. Okay. Cn. Cyanide is one of the strongest ligand possible. Okay. Cyanide and carbon monoxide, carbonyl and cyanido, these are very strong ligands. Always remember that wherever you see there is a carbon donor site in the ligand, that will be a strong field ligand. Same goes for oxalate. Oxalate also has a carbon donor site, that is also a strong field ligand. Alright. Yes, so this is a strong field ligand, and a strong field ligand will push the electrons and make them get paired up. So, if I have to draw the orbital, it will somewhat be like this. For D, there are 5 orbitals. Yes, so the 6 electrons, they will become like this, and the cyanide will take the hybridization of D2sp3. Am I clear? Yes, so how many unpaired electrons are there? 0 unpaired electron. Now let us solve it for FeH2O6 2 plus, okay. Similarly, here also see H2O, my dear bachos, H2O is a neutral ligand, does not have any charge. So that means that we can write it as X plus 6 multiplied with 0 is equal to plus 2. That means X is equal to plus 2. Am I right? Yes. So iron here also is in plus 2 oxidation state. That means iron in plus 2 oxidation state will be 3d6. But. Here is a but. Kahani mein twist. There is a twist in the story, and the story here is that H2O is a weak field ligand. H2O is a weak field ligand, and because it is a weak field ligand, what will happen? This time pairing up will not happen, and the orbital will look like this. Okay, see, electrons will look like this. Now see, this is how they will act. H2O is such a weak ligand that it will not be able to push the electrons and pair them up. It will not be able to push the electrons and pair them up. So that means that how many unpaired electrons are there? 4 unpaired electrons, my dear students. 4 unpaired electron. 1, 2, 3, 4. 4 unpaired electron. Okay. 4 unpaired electron. Okay. Alright, everybody. Understood? Yes. 4 unpaired electron, guys. Why 3? How are you guys finding 3? 4 unpaired electron, bacha. 3d6, no? 3d6, so 4 unpaired electron. Sai Charan, where are you having trouble, bacha? Where is it that you are not able to understand? Yes. Dattatreya, yes. Pretty much, Dhruv, pretty much, yes. Most of the ligands, okay, so I'll tell you what, in spectrochemical series, what happens is the anionic ligands are the weakest. Then comes the oxygen site, oxygen donor site. Then comes your nitrogen donor site, and finally you have the carbon donor site. So nitrogen donor sites are strong. Comparatively, nitrogen donor sites are strong field ligand. Okay? Alright, yes, Dhruv. Understood? Yes? No, this will be outer orbital complex, bacha. FeH2O6, the second compound, this is going to be an outer orbital complex. The first compound is going to be an inner orbital complex. Here the hybridization is going to be sp3d2. So this will be outer orbital high spin complex. Getting it? Getting it? Okay. Alright, everyone? Yes. Now let's take a look at the last one. Okay. The last one is COH2O6 and 2 plus. Am I right? Okay. So 2 plus, my bachos, 2 plus. And once again, everyone see H2O6. H2O is a neutral ligand. H2O is a neutral ligand. So, how do you calculate? X plus 6 multiplied with 0 is equal to plus 2. That means X is equal to plus 2. Now tell me, what is cobalt's atomic number? Cobalt has an atomic number of 27. That means it will be 3d7 4s2. But here it is in +2 oxidation state. So we can say that cobalt will be in 3d7 oxidation state, right? There are 7 electrons and see weak field ligand. H2O is weak field ligand. Okay. So here see everybody. This is how the orbital will look like. 1, 2, 3, 4, 5. Okay. 7 electrons, right? 1, 2, 3, 4, 5, 6, 7. Here we will have 3 unpaired electrons. So I think the option that is correct is, okay, 1 has the least, then it is 3, and then it is 2. So option A is your correct answer. Am I right, guys? Option A is your correct answer. Very good. Many of you are saying that option A is your correct answer. Well done, you bachos. Well done. Option A is your correct answer. Okay? Next question, guys. Next question. Okay? Yes? Yes. Do you have doubts, everybody? Do you have doubts regarding ligands? How many of you have doubts regarding ligands, guys? Let me explain this to you right away. Chalo. Let me explain this to you right away. How many of you have not studied anything about ligands, guys? How many of you have not studied anything about ligands, everyone? Yes. How many of you have doubts regarding ligands? Tell me quickly. Syed, VIT test you can give it from your home. Okay? You can give it from your home. You just have to book the slot. We will do that. Ikshita, we will do that. Don't worry. VIT EEE also we will be doing more classes. Yeah? Yes. Okay. How many of you do not know anything about ligands, guys? Do you want me to take you through ligands? Doubt in ligand. Yes. Tell me what are the doubts. I'm here. Tell me what are the doubts. Chalo, सबसे पहले, first of all, let us understand what are ligands, okay? Alright, what are ligands? First of all, let us understand what are ligands. So what happens is, understand this with a story. Let us understand this with a story, okay? Now you know the D block elements, okay? The D block metals such as iron, manganese, cobalt, you know, scandium, titanium, vanadium, chromium, nickel, all of these metals, right? They have empty d orbitals. Have you heard that? Have you heard of it, or have you read about that, guys? Tell me. Okay, see, we are going to interact and we are going to understand. Okay, we are going to interact and we are going to understand. So we all know that the D and F block elements, guys. Now please, I'm teaching you fully. Now don't ask me doubts in between. Okay, I'm teaching you from the beginning. So wait up. Wait up. कोई ऐप नहीं होता बच्चा, वेबसाइट होता है. सैयद, there is a website of VIT EEE, so you have to give the test in the website, not on the app. Okay? Yes, this is clear. This is clear. Again, ADTA, SNB, bachcha. Wait, no, I will come there. Wait, chill. Yes. So all the D and F block elements, the transitional elements, what do they have? They have empty d orbital. So now imagine if you are a house owner, okay? If you are a house owner and you have empty rooms, yes, where you are not staying, what will you do? You will rent it out. You will say that to let 1 BHK, 2 BHK, 3 BHK. You will be like, you know, give me money, I'll give you some room. Right? Right, everybody? Right? Am I right, everyone? Yes? Yes or no, guys? Yes or no? Absolutely. Now this D block elements, they have empty d orbital. That means they have empty d rooms, which they can rent it. And somebody, you know, there are some ions, okay? There are some compounds like H2O, you know, there are some compounds like NH3. There are some compounds like phosphine. There are compounds like, you know, F minus, or elements, elemental ions like fluorine 1 minus, chlorine 1 minus, bromine 1 minus. They can come and they want to have some, you know, they want to have some space to live. They're like, yes, we will take the rent and we will pay you. We will take the rent and we will pay you. Okay? Alright. So these ligands, when they come, yes, so see, when you want to rent it out to somebody, what do? You have a rent agreement, right? You write a rent agreement that every month you have to pay this much. Every month, you know, the bulb should not be broken, the tube light should not be broken, the fridge should be kept as it is, right? Right? Yes or no, guys? Yes or no? That happens, everyone? Does that happen, everyone? Exactly. So that's basically a bind. Your owner, the house owner, and you who is going to rent out the apartment, you both are in a bind, okay? You both are binding. There is a bond that you are sharing. Understanding, everyone? Yes? Is this understood, guys? That there is a bond that you all are sharing? Clear? Okay. So similarly, the metal and the ligand, they share a bond. Okay? Alright? They share a bond. Yes? Alright, everybody? Now, the metals, they have empty d orbitals. The ligands, they want to come and stay there. Acha, now tell me, the ligand, when they are coming, imagine if the ligands are relatives right now. Okay? Imagine the ligands are your relatives who are coming to your, okay? Imagine that the ligands are the relatives who are coming to your house. Okay? And sometimes what happens is, if you are a house owner, you know, you must have kept something in some room. Yes, and if somebody is coming to that house, you will have to clean up that room, isn't it? You will have to clean up that room, right? You will have to clean up that room, correct? Exactly. So sometimes if the ligand is very strong, you know, so sometimes imagine if you have a, you know, you have an auntie or an uncle who are very strict, what will happen? Or if sometimes your grandfather or grandmother, they are coming and they are very strict, what will you do? Your parents, they will literally clean the house completely, like, you know, this has to be here, this has to be there, this has to be there. Will they do it or not? Yes, they will do. Yes, they will do. But if your cousins are coming, you will be like, ayo, if my cousin judges my, you know, my test, if my cousin sees this pen I am using, if he or she sees that I am having the PS5, they will judge. So what do? Then you go and clean everything. You put everything in the cupboard. Like nothing should be seen. Nothing should be seen, isn't it? Exactly the similar way, when the ligands are approaching the metal, when the ligands are coming near the metal will be like, oh, somebody is coming, I have to clean up the room, I have to clean up the room, I have to clean up the room. They will go like this, and they will do what? They don't have rooms, they have orbitals. So they clean up the orbitals and they ask the electron, like, hey, psst, psst, go to that orbital, go to that room, you are not allowed here, go to that room, the ligand is coming. So what will they do? They will pair up the electrons. If somebody is very strict, if the ligand is very strict, what will happen? Pairing up of electrons will happen. If the ligand is like, okay, I will manage, don't worry, I will take a nearby hotel, you don't worry so much, yeah, I will take an Airbnb or guest house. So that ligand is weak. Then what will happen? See exactly what is happening. Now take a look at it. See, Fe, iron, when it is with cyanide, okay? If you have FeCN6, see what is happening, guys? FeCN6, cyanide is such a strong ligand that what will happen? So iron has orbitals. Iron has 3d orbital, it has 4s orbital, it has 4p orbital. Am I right? Yes. 3d, 4s, 4p orbital, right? Now cyanide will be like, no. You have to give me a room in your house only. I'm not going outside. I am not going outside. So cyanide will do what? 1, 2, 3, 4, 5, 6. Then cyanide will be like, okay, whatever is remaining that I will take. So see, cyanide will do what? Cyanide will take 1, 2, 3, 4, 5, 6, 7, 8, 9, 10, 11, 12. See, 6 cyanide are coming. 6 molecules of cyanide are coming. Each of them will have 2 electrons. So 12 electrons they are going to fill, and this will be your hybridization. Hybridization is D2sp3. And because cyanide said that, this will not work, I want a room inside the house. So what will you call this? This will be called as inner orbital complex. What will this be called? This will be called as inner orbital complex. And here you see, in each of the room there are 2 electrons. In each room there are 2 electrons. Am I right, everybody? Can you see that there are 2 electrons? In each of them there are 2 electrons. Now tell me, the electrons have spin, right? The electrons want to rotate, like they want to rotate. So if there are 2 electrons, that means they are fully filled. Will they be able to rotate? They will be rotating, but slowly. Hence we call it to be low spin complex. What do we call it? Low spin complex. Getting it? So this is low spin inner orbital complex. Clear? Clear everybody? Is this clear guys? Is this clear? I can see a lot of weird students here. See, now that I am teaching concept, somebody is asking, ma'am, concept, ma'am, concept, ma'am, concept. Bacha, what are you seeing me? What am I doing? Dancing? Huh? Can't you understand that I'm actually taking you through the concept? Literally taking you through the concept. What's wrong? Okay, now let us take a look at, FeH2O6. FeH2O6. Here see what will happen is, because this time you have a weak ligand, okay, you have a weak ligand, but Fe, iron has 3D, iron has 4s, iron has 4p, but H2O is like, H2O, see what will happen is, here the electrons are 1, 2, 3, 4, 5. All the electrons are filled in 3D, okay. So H2O will be like, you know what, don't bother, yeah, why will you push one electron here, another electron there? No worries, you know what, I'll take a room outside. This time see, iron also has a contact, in the same road he has a contact. He'll be like, bro, don't worry, chill, I have a contact, and here I have the 4D orbitals. Why don't you go and sit in the 4D orbitals? And that's exactly what H2O is going to do. Now see what H2O does, okay. H2O will take what? 1, 2, 3, 4, 5, 6, 7, 8, 9, 10, 11, 12. And this time the hybridization becomes sp3d2. Now because water said that, hey, I will take the outside room. What will be this complex? This will be outer orbital complex. This will be outer orbital complex. And because here you see, here there are 1, 1 electrons. Guys, take a look at it. Here you see there are 1, 1 electrons. So that means these electrons, if they want to spin, what will they do? They'll be like, zoom, they can spin, right? Very fast they can spin. So here we will call this to be high spin complex. Get it? We will call this to be high spin complex. Okay? Now, based on the unpaired electron, how many unpaired electrons are there? Yes, plus if you do 0.75, you will get the magnetic moment. So I can tell you right now, see, there are 4 unpaired electrons, the magnetic moment will be 4.8. Here there are no unpaired electron, the magnetic moment will be 0. If there is only one unpaired electron, then you should be able to calculate it faster. 1 plus 0.5, 0.75, it will be 1.75, 1.8. If there are 2 unpaired electrons, write it as 2.87. If there are 3 unpaired electrons, you can calculate it, it will be 3.83. If there are 4 unpaired electrons, you can calculate it, it will be 4.86. If there are 5 unpaired electrons, then the magnetic moment will be 5.87. Got it? Clear? Telugu lo illa. Telugu, I cannot speak Telugu. I'm not Telugu. Okay? Yes, I'm not Telugu, guys. You can go to the Telugu channel. This is an English channel. Okay? Alright, this is clear. Now what happens when a ligand is approaching? Guys, please understand this as a story. When somebody is, so you, let's say that your sibling, okay, or your brother, sister, and your mom and dad, right, you all stay in the house and you are all chilling, right? But if somebody wants to come to your house, what happens? You all start getting into the preparation. Today I have to prepare payasam. Today I need some, pappu I have to make. I need some rice and sambar also. There should be some chutney also, right? Everybody will go crazy. That I have to do this, I have to do that, I have to do this, I have to do that. Right? So when the ligand is approaching, the metal also starts getting there. The metal will be like, what to do. And there is a split. Okay? So what happens is, whenever there is a 6, they will go for octahedral splitting. What will be this? Yes, it will be H2O is a neutral. Yeah. My God, Hemant, Udish, bro, guys, if you ask me such questions 1 month before your exam. So neutral ligand does not have electrons. Who told you that? Neutral ligands don't have a charge. Like Cl minus, this charge it does not have. H2O does not have any charge. It is neutral. But electrons though it will have, na? My God, there is a mistake. It seems. See, look at Hemant. Hemant is saying that I made a mistake. H2O is a neutral ligand, so there should not be any electrons. Bro, what's wrong with you? Neutral ligand means that number of electrons, number of protons are same. It does not have an extra electron as a charge. You guys are crazy. Seriously. Queen Lucky, I don't know Telugu, Baba. How will I talk to you in Telugu? I told you, right? There is another channel, Vedantu Telugu. Go to that channel for EAPCET in Telugu. Here we can teach you in English only. Got it? Is this clear? So like I said, if there are 6 molecules that are approaching, okay? If there are 6 molecules that are approaching, there will be a splitting, okay? What will happen? These orbitals that you see, these orbitals, the d orbitals, they will be hyper, okay? They will become hyper and they will split. So that splitting is called as crystal field splitting. Got it? Clear? Sure. Now everybody, let us come back to the questions, okay? Here is another question for you. Let us take a look at the IUPAC name of the following complex. Guys, you must know the IUPAC complex, okay? You must know how to, you must know the nomenclature rules, everyone. So, let us try out the nomenclature rules here, everyone, okay? What is the nomenclature rule? The first rule, everybody, is, the first rule is that you will start naming the ligands first. Name the ligands first, okay? Alright? And these ligands, alphabetically you will name. So now you tell me that here NH3 is amine and H2O is aqua. Which one shall I name first? I will name amine because AM then AQ, okay? AM. So here there are 3 amines. So I am writing it as triamine. Triamine, okay? Then what will you write? See, there are 2 H2O, okay? So I will write as diaqua, okay? Then there is a chlorine atom also. So it will be chlorido, okay? Then see, the metal here is chromium. So I am writing here chromium. Then I will leave a space for the oxidation state, and outside here there are 2 chlorine, but that we don't have to write how many chlorine atoms are there. We will just write here chloride. Now let's find the oxidation state, okay? Oxidation state for chromium will be X plus NH3 is neutral ligand, so 3 multiplied with 0 plus 2 multiplied with 0 because water is also neutral ligand plus minus 1. Cl has minus 1. Now tell me here outside see Cl2. Cl will have minus 2 charge. That means this whole coordinate complex will be plus 2 charge. So here I am writing plus 2. Yes. So if I calculate it, 3 zeros are 0. 2 zeros are 0. X minus 1 is equal to plus 2. So X plus 3. So here I am writing 1, 2, 3 in Roman number and this is the name. Which means that option A is your correct answer. Clear? Yes? Option A is your correct answer. Alright everybody? Okay guys, chalo. Moving on to the next question. The next question is, which one of the following pair of complexes has the effective atomic number equal to 36 for the transition element? Okay, how do you find the effective atomic number, guys? Does anybody know how to find out the effective atomic number? How do you calculate the effective atomic number? There is a formula. Chalo, let me tell you guys. Let me tell you. The effective atomic number, you can calculate it as atomic number of the central atom, atomic number of central metal ion, okay, central metal ion minus oxidation state of central metal, okay, plus whatever is the coordination number, multiply it with 2. Yes, coordination number is basically how many number of ligands are attached. Very good, NK. Very good, very good, very good. Well done. Chalo. Now, see, I know the answer is option C. Okay, I know that the answer is option C. So, I'm going to calculate it for you and I'll show it to you. Okay. So, effective atomic number, let us calculate. Now, what is iron's atomic number? Iron has an atomic number of 26. Okay. Now, see. CO, carbonyl ligand is a neutral ligand. Okay. So, if it is a neutral ligand, that means X plus 5 multiplied with 0 is equal to 0. That means X is equal to 0. So, the oxidation state of iron here is, oxidation state of iron here is 0. Plus, what is the coordination number? 5 ligands are attached. So, 5 multiplied with 2, if I do, I will be getting 36. Okay. See, for option C is the correct answer, guys. Option C is the correct answer. Telling you, option C is the correct answer. Okay. Now, see, for the next one, if I do effective atomic number, for the next one, if I do, which is K4FeCN6. Can you see? K4FeCN6. Okay. Alright. Yes. Here, see, once again, iron has 26 minus. Okay. Right here, if you calculate it, Cn has a -1 charge, guys. Cn has minus 1 charge. So, if I find out the oxidation state, it will be X plus 6 multiplied with -1 is equal to -4. So, X is equal to plus 2. So, here I am going to write 2 plus 6 multiplied with 2. If you calculate it, you will get 36. Okay. Alright. You will get 36. Alright. So, that means that option C is your correct answer. Clear? Option C is your correct answer. Sai Charan, I have already told bacha. Can you please forward it and watch it, or please watch the coordination compound chapter. I will tell you where you can find it. Okay? I will tell you the coordination compound chapter. Don't worry. Okay? Yes, lost it. It is still possible. The questions are very easy. You can do it, but you need to answer. Okay? Yes. Okay? Alright? Chalo guys. Moving on to the next question. Let us go to the next question. Okay. See, this type of question will come, bacha. I can guarantee that this type of question will come. This is from Werner's theory, okay? This is from Werner's theory, so please learn this. See, when AgNO3 solution is added in excess to 1 molar solution of COCl3.xNH3, 1 mole of AgCl is formed. What is the value of X? Okay, so here this is going to be very easy, everyone. Just take a look at it. What are they saying? That you have a compound. See, you have a compound which is COCl3.xNH3. Okay, this is the compound. Then they are saying that AgNO3 you are mixing. Okay, what are you doing? You are mixing here AgNO3. Okay, so let us add here AgNO3. Okay. Now, when you do AgNO3, what are you getting? You are getting 1 mole of AgCl, okay? If you are getting 1 mole of AgCl, that means that this compound, okay, this complex will be sort of like this, CONH3. There will be 2 Cl inside and there will be only 1 Cl outside. If you know that this outside Cl, this is called as counter ion, and whatever is inside, that's called as coordination entity, coordination sphere. So here there will be 4 plus 2, this will be an octahedral complex. So that means what is the value of X, guys? The value of X will be 4, isn't it? The value of X will be 4. Okay? Alright? Yes? Kanika, it could be useful, okay? It could be useful, yes. I'm not very sure if the question will come, but this type of questions definitely comes in each and every exam. It even comes in JEE, it comes in VIT-EEE, it comes in SRM JEE-EEE, it comes in EAPCET, everywhere it comes, okay? Alright? Yes. Did you understand, everyone? Chalo guys. Moving on to the next question, everyone. Yes? Okay. So what is this type of isomers, guys? What are this type of isomers? See, CO, NH3, 5, SO4, Br is outside, Br is the counter ion. In the next compound, SO4 is the counter ion and Br is inside, okay? And this type of isomers, my dear students, it is called as ionization isomer. That means that the counter ion also has, potential. Counter ion has potential to become a ligand, okay? To become a ligand. Am I clear? That is called as your ionization isomerization. Cool. Okay, everybody understood? Very good. Next question, everyone, is what is the coordination of the metal in COEN2Cl2? Now, En is a bidentate ligand. What is En? En is a bidentate ligand. That means that 2 multiplied with 2 will be 4 and there are 2 number of Cl. Okay, 2 Cl are there. So 4 plus 2 is 6, option D. This is an octahedral complex. What about a ligand isomer? Does anybody know what is a ligand isomer, guys? Does anybody know what is a ligand isomer? Does anybody know what is a ligand isomer? Come on, guys. There are different types of isomer. Yes? Okay. So what happens is there are ligand isomers are basically, you know, in organic chemistry you study that what happens is when the ligand is attached to different position, that's called as a ligand isomer. It's a type of structural isomerism, okay? For example, you know, okay, for example, I'll give you one example, okay? There is 1,2-diaminopropane, 1,2-diaminopropane, and there is 1,3-diaminopropane. So that's called as a ligand isomer, okay? That's called as a ligand isomer. Clear? All right? Yes? No. That's ambidentate ligand, guys. That's ambidentate ligand. That's ambidentate ligand. No. Okay? Yes. Okay? Understood, everybody? Arey bhai, Manikanta, please go out of the class. Please go out of the class. You don't have to study. Go out of the class. Just go out of the class. Time complete. Send this session. I will send you this session. Huh? What do you think? You have hired me as your personal teacher or what? I will send you this session and time complete. Don't study. Go. Chalo, guys. Next question. Okay. The correct order for wavelength of absorption in the visible region of the following complexes will be what? Okay, guys, so let me tell you, everybody, here we will be using spectrochemical series. If all the students who were asking, ma'am, what to do spectrochemical series, ma'am, which one is what is what, right? Chalo, let me tell you here, okay? See, you guys know that from this side to this side, okay? So you remember, I have told you, I have given you some mnemonics, everyone. Yes, I have given you some mnemonics how to remember the rays, the absorption spectra. What is the absorption spectra mnemonic? It is can't get X, U, V in my range. This means cosmic, gamma, X-ray, UV, visible, infrared, microwave and radio wave. So as you go from this side to this side, what happens? The wavelength increases and the frequency decreases. If the frequency decreases, that means the energy decreases, okay? Yes. And if the energy decreases, that means you have to understand that weak field ligand will be absorbed this side, okay? This side you will have weak field ligand and this side you will have strong field ligand absorbing it, okay? Alright, everybody. So now tell me, which one is the weak field ligand? See, there are H2O, N2O, NH3. What do you have? You have H2O, N2O and NH3, okay? Alright, so here see, what do you have? Weak field ligand. The weakest field ligand is H2O. That means lambda has increased. Lambda has increased for H2O. After that, what do you have? The next wavelength that you have is NH3, okay? After that, NH3 will be somewhere here, okay? NH3 will be somewhere here and N2O or NO2 will be somewhere here, okay? So because of that, everyone, because of that, option B is your correct answer, Okay, N2O or NO2, sorry, NO2 will have the highest energy that it can absorb because it's a strong field ligand. Then it is NH3 and then it is H2O. Okay, out of these three, H2O is the weak field ligand. Okay, out of these three, and H2O is weak field ligand. Clear everyone? Yes? Chalo guys, moving on to the next question. Yes, the next question is, which among the complexes are named, can be named dichlorido bis ethane 1,2-diamine platinum 4 nitrate. So wherever nitrate is outside, okay, see in this one nitrate is inside, so this is not the answer. In this one nitrate is inside, this is not the answer. In this one also nitrate is inside, not answer. This is the correct answer. Option A is your correct answer. Okay, option A is your correct answer. All right guys, next question. The oxidation state of cobalt in KCOCO4 is, everyone, chalo, let us calculate everybody. Let us calculate this. Yes, let us calculate this everyone. The last one, shall we calculate this everybody? Yes, see, there is K plus. If there is one K plus positive, that means that COCO4, this will be negative, 1 negative. So what we will do is X plus, CO is a neutral ligand, so 4 multiplied with 0 is equal to -1. That means X is equal to -1. So the oxidation state of cobalt is -1. Okay, it will be -1. Next question guys. The Wilkinson catalyst in the hydrogenation of alkenes is, okay, the Wilkinson catalyst, everyone, the name of the Wilkinson catalyst, everybody write this down. It is chlorotris, okay, chlorotris triphenyl phosphine rhodium, okay, rhodium 1 oxidation state. So that means option B is your correct answer. Okay, option B is your correct answer. And the last question everybody is, this is very important, please do this everyone. Ml6N plus, it is an octahedral complex. Its crystal field splitting energy is given to you. If the same metal forms a tetrahedral complex with the same ligand, then what will be the crystal field splitting energy for the same, for this complex, and that too you have to find it in delta EV. Okay, sorry, not delta EV, that too you have to find it in electron volt. Okay, because there are 4 ligands everyone. Okay, because there are 4 ligands, and we know that for delta tetrahedral it is 2/3 of delta octahedral. Okay, yes, what is this? This is 2/3 of delta octahedral. Okay, so now we know that delta tetrahedral is going to be equal to 4 multiplied with 2/3 multiplied with delta octahedral has how many ligands guys? So let's write here 6, because there are 6 ligands. 6 ligands will be occupying the space, right, in octahedral complexes. Yes, absolutely, very good. Okay, now take a look at it. So 4 multiplied with 2/3 multiplied with delta octahedral is given to you as 1.8 divided by 6, right? So now let's do this. 2 here and this will be 3. So 3 multiplied with this will be 0.6. Now 4 multiplied with 0.6, it will be 2.4 divided by 3. That means that this will be equal to 0.8 electron volt, and correct answer is option B. Okay. Alright, which complex exhibits potential candidate for information storage, ma'am? Hey? Information storage, I think that's biology that you are asking. Bro, I don't teach you bio, I teach you chemistry. Okay, so guys, that's it. These are your questions that we have solved today. Correct answer is 0.8. With this note, thank you so much. I really hope that you found this session useful and you liked the session. If you did, do not forget to hit the like button and let us know in the comment section that you want more session. I'll bring you more questions. And everybody, let me also show you one more thing. So this is our YouTube channel, everyone. You will find that I'm searching for our YouTube channel. Right here, everybody, right here, see Vedantu JEE English. I have searched for it and I have clicked on it. Here, see, this is our Vedantu JEE English channel. Okay. Now, in this channel, okay, if you go to the video section, and then if you go down here, okay, or just search here, guys, see everybody, see, look at it, see, I'm showing you here, see, here is a search button, so search for search for coordination compounds JEE English. Okay, if you search for it, see, you will be getting this. Can you all watch this session? Please watch this session, everyone. See, this has already 78,000 students that have watched. Watch this session. I promise you, every single topic that you are finding it difficult in coordination compound, you will be thorough with the session. Okay, you will be thorough with the session. So please watch this session. All your doubts related to coordination compound will be done. I'll be sending you this PDF in the Telegram channel, everybody. Yes, I'll be sending you this PDF in the Telegram channel. Do join the Telegram channel, and you can also join my Telegram channel, which is Nabamita. No, sorry. My Telegram channel is Nobita Ma'am. Okay, you guys call me Nobita Ma'am, no? So my Telegram channel name is Nobita Ma'am. You can follow me on Telegram. If you want, you can also follow me on Instagram. Instagram, it is Nabamita aka Nobita Ma'am. Okay, all right. So you guys can follow me. I'll see you there. Tata, bye bye. Lots of love. You have your math session coming up, so stay